Hey guys, so today we're tackling day 2 of our last section of this chapter, which is section 5.5, multiple angle and product to sum identities. These are the last bit of identities that you're going to learn how to use and apply when solving trigonometric equations. So in day 1 of 5.5, we talked about our double angle identities and use them in examples, and also our power reducing identities. In today's lesson, we're going to be talking about the half angle identities and how to use those. And so if you notice, all of the identities are titled exactly as they sound, right? So double angle identity, when you have double of something, you're having double the angle. That's why there's 2 theta, 2 theta, 2 theta all across here inside your sine, cosine, and tangent functions. Power reducing, obviously that refers to reducing the power, and the power is your exponent. So how do you reduce this exponent from sine squared and make it to have no exponent here, right? And the same thing goes for your cosine squared. How do you have that to make it no exponent, and tangent to have no exponent? And then today, the one that we're handling is the half identities. And so half angle, again, it's half of the angle. So theta divided by 2, theta divided by 2. How do you change that so that we could just have our answer in terms of just theta? We're always looking to have our answer just in terms of theta. All right, so moving along, let's tackle some of these problems by using the rules that I have just showed you. So in this first one, it says that you want to evaluate an expression involving a half angle. So it's saying find the exact value of cosine of 102.5. All right, so I am already directed to use the half angle rules, and I know that if we're talking about cosine here, I know that cosine of theta over 2 is equal to plus or minus radical 1 plus cosine of theta all over 2. And if you look, you could confirm that is right here. All right, so first I'm going to ask myself, what must theta be? What is theta? If theta over 2 is equal to 112.5. Well, if I multiply by 2, then I'm going to get my theta. And if I multiply this angle by 2, I'm getting that theta is actually equal to 225. With that being said, I can now substitute this and find out what is that value. So I'm going to do plus or minus radical 1 plus cosine of 225 all over 2. And I can draw where 225 exists because I know that the cosine of 225 is the cosine of 180 plus 45. All right, so we're doing the cosine of a sum. This takes you back to another set of rules that we did earlier on in the chapter. And the cosine, the sum of cosine is cosine. Remember, if this is alpha and this is beta. So we're doing cosine of alpha times cosine of beta plus, minus sine of alpha times sine of beta. All right, I can deal with this. I can deal with 180 degrees and 45 degrees because those are easy. 180 degrees is right here, and it's negative 1, 0. So your cosine is negative 1, your sine is 0. And 45 degrees is right here. 45 degrees is our 1, 1 radical 2. And so it's easy to get the sine and cosine for that. So the sine or the cosine of 45 is SOH, which is adjacent over hypotenuse, and our sine of 45 is equal to opposite over hypotenuse, which is 1 over radical 2. Great, now I could input all these values in here and solve the cosine of 225 to put it back into this. All right, so cosine of 180 Here's 180, that's -1, times the cosine of 45, which is 1 over radical 2, minus sine of 180 is 0. So this whole thing goes to 0. So this is -1 over radical 2. So I could put that inside here. So now I have plus or minus 1 minus 1 over radical 2 all over 2. And if I do some algebra, get a common denominator, then I have radical 2 minus 1 over radical 2 divided by 2 all under the square root. And keep, change, flip tells me that I do keep the first fraction, change the sign to multiplication, and flip the second fraction. Instead of 2 over 1, it becomes 1 over 2. And so this becomes radical 2 minus 1 over 2 radical 2. And we could do a little more simplification here by taking out this radical on the bottom. So I'm going to multiply by radical 2 over radical 2 and rationalize that. Give me 1 second while I erase some of this work up here so I have some space to move around. All right. All right. All right. Now that I have some space up here, I'm going to go ahead and continue that math. So I'm going to distribute this radical 2 to everything on top. So radical 2 times radical 2 just gives me 2, minus 1 times radical 2 is just radical 2, over, when I multiply this times that, that's just 2, that's 2 times 2, that's 4, all under the square root again. So I do know what the square root of 4 is, and that's 2, so I could take that part out of the square root. So I'm left with plus or minus the square root of 2 minus the square root of 2 all over 2. And there you have it. So 2 minus radical 2 under the square root and 2 outside. All right. Now there's one thing to think about here, and that is that the original angle, where did it lie? Because we have two answers here. We have plus and minus, but we need to think about where did this original angle lie. That original angle lies over here. We have 180 plus 45. It lies right here, right? That's 225. So 225 degrees right here is going to give me a cosine that is either positive or negative. Which one is that? Well, we go to our acronym. All students take calculus to find that out, and that means that we would only have the negative answer. So we would only have the negative radical 2 minus radical 2 over 2. That is our final answer for this one. All right, let's move on to the next one. This is the half angle identities. So again, we're dealing with the same identities that we used to solve the last problem. Here you have the sine of 2x is equal to 2 cosine squared of x over 2. So the first thing I want to do is I want to get rid of this half identity. And to get rid of that half identity, I'm going to use the cosine rule. So that cosine of theta over 2 is equal to plus or minus 1 minus cosine of theta over 2. So I'm going to go ahead and plug that in here and leave everything else the same. So I have sine squared of x equals 2. Instead of cosine squared of this, I'm going to do this squared, okay? So I'm going to take that, and because it's squared, I'm going to square it. All right, now I could simplify. I have squared and I have a square root. They cancel each other out beautifully. So now I have sine squared of x is equal to 2 times 1 minus cosine of theta over 2. 2 over 2 cancel out beautifully. Now I have sine squared of x equals 1 minus cosine theta. Sorry, the original rule was plus. I don't know why I put minus. So that's plus all the way down. So I have sine squared x equals 1 plus cosine. All right, great. Now I cannot solve this just yet because I have two different types of terms. I have a sine and I have a cosine. But I see that this has an exponent, so I'm going to change this one using the power reducing rules. And the power reducing rules tell me that sine squared of x is equal to 1 minus cosine squared of x. So I'm going to use that to replace this, and then I have it all in one term. I have cosine here, and I'll have cosine here. So 1 minus cosine squared of x is equal to 1 plus cosine of, oh, I just noticed I'm using x and theta at the same time. So I'm just going to switch over to x. All right, I'm going to minus 1, that goes away. So I'm going to plus cosine squared x plus cosine squared x. So I have cosine squared x plus cosine x equals 0. And now I can factor. I have cosine times cosine plus 1 equals 0. So I have two equations here. One is cosine x equal to 0, and one is cosine x plus 1 equals 0, which means that cosine of x is equal to -1. So whatever angles make these values true is my answer. So when is the cosine of x equal to 0? Let's tackle that one. Well, cosine is your x value. When is your x value equal to 0? Your x value is equal to 0 here and here. Therefore, x is equal to pi over 2 and 3 pi over 2. All right, let's tackle the second equation, which states that cosine of x equal to -1. When is cosine of x equal to -1? Well, the x value is -1 over here, which is at pi. And so that adds a third answer here, and that's pi. I hope you guys paused the video and tried these on your own before watching my step-by-step. Let's move on to some new identities. And these are your last identities you're going to need to know how to use for this chapter. All right. Go ahead and take a second to write this down. These are the new identities. These are the product to sum identities and sum to product identities. So as it is stated, it's taking a product and turning it into a sum. So you have sine alpha times sine beta, and you're moving it into addition or subtraction sentence. And then you have sum to product, where if you have the addition, you're moving it into a multiplication sentence. Okay, and this is how you do it, by following these rules. So again, we're just applying the rules. All right, so let's go ahead and practice. So this first one says use an identity to write a product as a sum or difference. So we're going ahead and we're taking a product and we're moving it to a sum or a difference, okay? So we have cosine of 5x times sine of 3x, and we want to put it as a sum or difference. So looking back at our rules, we have cosine times sine. So which one of these guys is going to give me cosine times sine? And you have this one right here, cosine times sine. That's the rule that we want to use. All right.
Miss, may I have to the first grade, please?
So I'm going to call this alpha, I'm going to call this beta, and I'm going to go ahead and write my rule under here. Cosine of alpha times sine of beta is equal to 1/2 sine of alpha plus beta minus sine of alpha minus beta. All right, now that I wrote that rule, I'm going to go ahead and plug everything in here. So I have 1/2 sine of, I'm adding both angles, so I'm adding 5x plus 3x, which is going to give me 8x minus sine of, I'm going to subtract them now, so 5 minus 3 is 2. So I'm going to go ahead and distribute the 1/2 to everything, and I have successfully now written it as a sum or difference. In this case, difference, because it's subtraction. But I wrote it as a difference. It's no longer multiplying anymore. You have two terms and they're being subtracted. We're done. All right. So this one, you are going to take that sum and find the value, okay? So let's go ahead and look at the rules that are associated with this one. And you have here that you can reduce this addition sentence by making it a product. And so I want to think first, I want to go to my rules, and I'm going to go back to my rules and show you guys. I was looking at it in my notebook, but let's look at it all together, okay? So the question was asking the sine of 5 pi over 12 plus the sine of pi over 12. So I'm going to look over here and I'm going to see which one of these is saying sine of one angle plus the sine of another angle, and that's this very first one right here. And so that's what I'm going to use. So that tells me that I'm going to do the sine of alpha plus sine of beta is equal to 2 sine alpha plus beta over 2 times cosine alpha minus beta over 2. Right? If this is alpha and this is beta, my first step is to figure out what is alpha plus beta over 2. So alpha plus beta over 2 is 6 pi over 12 divided by 2, which is the same thing as multiplying by 1/2, which is 6 pi over 24. Which you could divide 6 on top and bottom and you get pi over 4. So I can go ahead and insert that back in here. So that's 2 sine pi over 4 times the cosine of, let's figure this one out. So we're going to do alpha minus beta over 2. Alpha minus beta is 5 pi minus pi, 4 pi over 12. And you can reduce this, divided by 2 first. Don't forget that. So after you subtract, you're dividing by 2, which is multiplying by 1/2, which is 4 pi over 24. Again, I could reduce this, divided by 4 on top, divided by 4 on bottom, and I have pi over 6. All right, now that's done, I could find the exact value because that's what the question is asking me to do. It's telling me to find the exact value. You're looking for a number answer, and I could totally find the number answer because I know what pi over 4 looks like, and I know what pi over 6 looks like, and I know I could get the sine and the cosine of those angles. So I'm going to draw pi over 4 right here, which is pi over 4, which is 1 radical 2, and I know what a pi over 6 looks like, and that is pi over 6 is 30 degrees, so it's 1 across from here, 2 across from here, and radical 3 across from here. Okay, so the sine of my pi over 4, sine is opposite over hypotenuse, so looking over here, opposite over hypotenuse, that's 1 over radical 2. And then the cosine of pi over 6 is adjacent over hypotenuse, which is radical 3 over 2. And now I'm just going to do some math over here. So I have 2 radical 3 over 2 radical 2. I could cancel out the 2 on top and bottom. I have radical 3 over radical 2. I want to rationalize the denominator, so I'm multiplying by radical 2 over radical 2. This gives me radical 6 over 2, and that's my answer there. I got an exact value. All right, here's our last example right here, and we're going to solve this sum to product identity here. So I have basically a cosine of alpha plus a cosine of beta equals 0 situation. I'm going to go back up to my rules and I'm going to see what can I do with a cosine alpha plus cosine beta situation, and I have that written right here. So I'm going to take that rule and grab it, and I'm going to do cosine of alpha plus cosine of beta is equal to 2 times the cosine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. So I'm going to start plugging things in. So 2 times the cosine of alpha plus beta, alpha is 4x, beta is 2x, 4 plus 2 is 6x, 6x divided by 2 gives me just 3x. times the cosine of alpha minus beta. So alpha minus beta is 2x divided by 2 is just x. All right. Now I have this is equal to 0. I could divide both sides of the equation by 2, and now I'm finally left with the cosine of 3x times the cosine of x is equal to 0. I can solve this by setting up two equations here, cosine of 3x equals 0 and the cosine of x equals 0. All right, when is cosine equal to 0? Cosine is equal to 0 when x is equal to 0, and that is here and here, which is pi over 2 and 3 pi over 2. So here you would have x is equal to pi over 2 and x is equal to 3 pi over 2. This one is a special case, this one, because you don't have just theta, it's 3 times theta, or 3 times x. So 3x is equal to these answers, and you need to solve for just x. So 3x is equal to pi over 2, 3x is equal to, sorry, I wrote that wrong. 3x is equal to 3 pi over 2, and divided by 3, which is the same thing as multiplying by 1/3, divided by 3, which is the same thing as multiplying by 1/3, and you get that x is equal to pi over 6, and x is equal to pi over 2. Okay, because you cancel out that 3 there, cancel out that 3 there. All right, this answer and this answer is redundant. So far you see that you have 3 answers. You have pi over 2, pi over 6, 3 pi over 2. All right, and you always want to support your answers graphically, because while algebraically we got 3 answers, when you do it graphically, you're going to get 3 more answers on an interval from 0 to 2 pi. So you always want to check the answers graphically. So when you check it graphically, you get this answer, you get this answer, you get this answer, but then you also get that it exists at 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right. And that's it, guys. Now you're able to complete the rest of the problems on that 5.5 worksheet. Please text me if you have any questions, and I'll see you later. Bye-bye.